Okay, so today we're going to do our first little bit of naming and formula writing. And we're going to start with one, well, we'll do two today, but we're going to start with one specific type of compound, and that's compounds that have just nonmetals, so things from the right side of that staircase in the dividing line in the periodic table. And this first one is CO2, better known as dry ice. So all I want you to do is think about what the name of this thing is. What is a systematic chemical name for this formula CO2? And I start with this one because you've heard it before. You know this is what you breathe out. You've all seen solid carbon dioxide. You set it in the sink and it just turns into a cloudy gas. And this is called carbon dioxide. So carbon, that's the first one there. And then two oxygens, and it's ended in IDE. So this is carbon dioxide. And what we use are these Greek prefixes. You know a lot of them, maybe you don't know all of them, but mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. So like here is di, it means two oxygens, so two oxygens. There is no prefix on the carbon, the first one. There's only one. And on the first thing, on the first word, we don't use mono. If there's only one, we don't use it. If there's more than one, we'll put one of these prefixes. So if you have two nonmetals bonded together, like carbon and oxygen, it's a specific type of compound called a covalent compound, and we use these Greek prefixes. If you go to another example, just CO, so not CO2, but CO, the name of this one is pretty similar, but it's carbon monoxide because it's one carbon and one oxygen. So instead of dioxide, it's monoxide. It still ends in IDE, and you'll note that all of these end in IDE. Another example might be CO3, so a carbon and three oxygens. So it's carbon trioxide. One carbon, three oxygens, still ends in IDE. We have an example like SiO2. You better know it. You know it better. It's sand, but its chemical name, its systematic name is. If you look at here, we have one silicon and two oxygens, so it's silicon dioxide. One silicon, two oxygens. We go to something you're familiar with, H2O. You all know that formula. It's water, but it has a systematic name, and it's two hydrogens, one oxygen. So this is dihydrogen monoxide. Another example would be C3H8. So a few more things in it, but it's three carbons, eight hydrogens. They're both still nonmetals. All of these are nonmetals. So if you have more than one type of nonmetal bound together, things from the right side of the periodic table, this would be tricarbon octahydride. Three carbon, eight hydrogens. And they all end in IDE. And the key here is that they have something in common, like the second word, always you lop off whatever ending the word has and replace it with IDE. There's always a prefix on that second word. Even if there's only one, you use mono. There's only a prefix on the first word if there's more than one. So you just don't use mono. You don't say monocarbon dioxide, monocarbon monoxide. You just, if there's only one of the first thing, carbon, 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 you don't use the word mono. But if there's only one of the second thing, like right here, you always put a prefix on the second word. Okay, so this is covalent bonding. This is, and we'll talk later about what that means, but basically it's the sharing of electrons. And it's where two different things from the right side of the periodic table, so the nonmetals. Remember, this is metals over here, and these are nonmetals, including hydrogen belongs over here with the nonmetals. So when you bond two nonmetals together, it's this system of formula writing, and it uses those Greek prefixes. So CO2 is a carbon and oxygen, two nonmetals, and you call it carbon dioxide. One carbon, two oxygens. So you use these Greek prefixes, and if you look on your periodic table down at the bottom, you don't have to memorize these. These are all, they're down there in a table at the bottom of the chart. You'll just get used to them, and pretty soon you'll know them all. Like, you probably know most of them. You might not know tetra, hepta, nona. You might not know those, but you know mono, di, tri. Okay, so the systematic way of doing this. The rules of naming covalent things are the second word ends with IDE. Whatever its word is, you lop off its ending and replace it with IDE. So carbon becomes carbide, oxygen becomes oxide, phosphorus becomes phosphide. They always end in IDE. That's the second word. And the second word always gets a prefix, even if it's just mono. The first word gets a prefix if there's more than one. So you just don't put mono on the first word. Okay, so that's basically how it works. So some examples here. If you take a second to think about it, H2O2, you probably know this is peroxide. You might have some at home in the bathroom. But this is 2 hydrogen, 2 oxygen. So you call it dihydrogen dioxide. 2 hydrogen, 2 oxygen, but the second word is ended with IDE. NBr6, they have 1 nitrogen, 6 bromines. These are both from the right side of the periodic table, so this is nitrogen hexabromide. You don't put a mono on the first one. The second one, there's 6, so it's hexa, and then not bromine, but bromide. You just end it with IDE. Knowing that it ends with IDE means it's in a compound. And another one, O8Cl10, so you have 8 or octa oxygens and 10 or deca chlorines. So it's octoxygen decachloride. And that's it. That's pretty straightforward for these covalent compounds. But within those compounds is a special set of things called the diatomics, and there are 7 of them. And this is its own little system of naming and formula writing. And as an example, the first one we're talking about is hydrogen. If you just see the word hydrogen, it's not bound to anything else. It doesn't say hydrogen monochloride, or it doesn't say iron hydride, anything like that. It just says hydrogen. The formula is H2. It's because hydrogen doesn't exist as one single atom floating around. It exists as 2 hydrogen atoms bound together. It's still a covalent compound. It's still 2 nonmetals, but it's the same nonmetals. This is elemental hydrogen, and this is how it exists in the universe. That's also true for nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. They do not exist as a single atom floating around. So if you see the word oxygen, it doesn't say oxygen trichloride or anything like that. It's just oxygen all by itself. The formula is O2, but you're probably familiar with that one because that's what you breathe. 80% almost of the atmosphere is nitrogen, and when you see the word nitrogen, just nitrogen, not any other word with it, it doesn't say dinitride or fluorine tetranitrogen, anything like that, just nitrogen by itself. The formula is N2. If you see Br2 by itself, not HBr2, not PBr2, just Br2, the name is bromine. Cl2, the name is chlorine. I2, the name is iodine. These 7 things are a special case, and they have their own system of naming and formula writing. So if it's just any of these things by themselves, the name is just the unchanged name. You don't add IDE, you don't add a prefix, it's just the name. So again, these 7 diatomics, it's nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. They kind of make a 7 over here, and if you want, you can draw a little 2, a little subscripted 2 to denote them as the diatomics. And them being diatomics, it doesn't, if you put that 2 there, it doesn't change the mass. Like nitrogen is 14.00. That's still the mass of 1 nitrogen. So if you were to have the word nitrogen, it means N2, and that the mass of that, the molar mass, would be 28.02. It's still, you have to double the mass because it's 2 atoms. But this is a special case for just those 7 because that's how